Hello students, today in this video I am going to explain paging, basic concepts about paging, why paging is required, and then what is the difference between the logical address and as well as physical address. So the first one is paging. Paging means here we know that the memory is divided into frames, right? And in that we already discussed about contiguous and non-contiguous memory allocation scheme. Contiguous allocation means what happens if a process comes of 10k, okay? In contiguous memory allocation, this 10k whole process is stored in one memory location, that is here. Whole 10k one process, suppose the process P1. This is contiguous, whereas a non-contiguous memory allocation means what happens if a process 10k comes, in that 8k may be stored here, okay, then remaining 2k may be stored here. So process P1 is divided here, P1, right? 10k a single process, it is divided 8k stored here and 2k is stored here. This is non-contiguous, where this one is a contiguous memory allocation scheme, and this is having advantages and as well as disadvantages. What are the advantages of contiguous memory allocation? Whenever a process P1 comes, you want to take or to address that process P1, it is very easy, because if you give the starting address here, the whole process you can take out from the memory. Whereas in case of non-contiguous, what happens, you have to search the process P1. Why? Because P1 is distributed in the memory. And the paging is a non-contiguous memory allocation scheme. So paging means what happens in case of paging, your memory is divided into frames here, frames or fragmentation here. So here, and each page or the block, the memory block, are of same size, right? And even the secondary memory, this is we consider as a main memory, and this one is secondary memory. And in secondary memory also it is divided into, see, these are the, it is divided into frames or pages like this, okay? Now these are fixed size blocks. If this is 5k, this one is also 5k and this one is also 5k. Even in secondary memory also we should follow the same method. Everything should be 5k. Yeah, in this example I have taken as 5k, that may differ, so maybe 10k, 10 MB like that. So what happens in the main memory and as well as secondary memory, it is divided into fixed size blocks, each block of fixed size, and this one we call it as paging. So what happens if you consider a main memory and as well as the secondary memory, they are divided into fixed size pages. And paging, why we require this paging, why it is of fixed size? See, if it is of fixed size, then what happens, it is very easy to map the process which is stored in memory, main memory, to the secondary memory. So in the main memory, what happens if a process P1 comes, okay, it is a non-contiguous memory allocation. If a process P1 comes, P1 is distributed here. Then what happens if you want to store it into the secondary memory, there is no need to search the space in the secondary memory which is large enough to hold the process P1, because secondary memory is also divided into fixed sized blocks. So this is also 5k, this is also 5k. You can put this one anywhere here, this also you can put anywhere here. So if the memory is not divided into fixed size blocks, then what happens, if it is a secondary memory, one of the block may be 10k, one of the block may be 2K and another block may be 20K. Then what happens, if you want to put the process P1, you have to search, okay, which block is free and which block is large enough to hold your process. So in order to overcome this paging scheme is introduced, where the main memory and as well as the secondary memory, it is divided into fixed size page or the fixed size blocks. Usually a page size is 2 power, it is usually usually we represent in size of 2 power n or m, like this. So what happens, if the page size is 2 power n, it varies between 512 bytes and 16 megabyte per page. Okay, it depends on the computer architecture. Usually page size, it will take it as 512 bytes or 16 MB per page. That means each page, each block, here I have written 5K, but usually it will be 512 bytes or 16 MB per page. Okay, now this is the concept about paging. You know, paging means what? The memory, it is divided into fixed size blocks. Okay, that is called paging, and so that it will help to map the memory here. What happens, if we want to store it in secondary memory, it will be easy for us to store the process in the secondary memory. Now we will discuss about the difference between the logical address and physical address. Okay, logical address and the physical address. Now what happens, logical address and physical address, we will discuss that. So I will show one diagram, okay, which is given in the book itself. Now you can see here he has given that if the size of the logical address space is 2 power m and the page size is 2 power n, that means what? For example, consider page size is equal to 2 power n and the size of the logical address space is equal to 2 power m. Okay, have you understood this one? Page size is 2 power n and logical address space is 2 power m. Then what happens? The higher order m minus n bits, they use to designate the page number. Okay, whereas the lower order n bits, they act as offset. Okay, now please understand the difference between logical and physical address. First, we know that this is the page. Okay, page size is fixed. If the page size is equal to 2 power n and the logical address space is 2 power m, we know page size, but what is this logical address space? Okay, now see here. Okay, can you see the diagram over here? Okay, now see, this is the logical memory. Okay, in this logical memory we have addresses 0 to 15. Okay, let me write here. Logical memory. Logical memory means just what we have written any program or the process. It occupies the memory and there some address is given to that. It is not the physical address, it is just a logical address. Suppose if you have written some program, okay, program starts from address 0. Okay, next it will start 1, 2, 3 like that. Now 0, 1, 2, 3. Okay, they have taken this as an example. Now 4, 5, 6, 7, E, F, G, H. Okay. Assume this is something, it is written and it is divided into pages. This is one page. Okay, so this you can consider as a page. Now what happens? How many bytes are stored in one page? This is 1 byte, 2 byte, 3 byte, and this is the fourth one. So page size is equal to how many bytes? 4 bytes. That is equal to 2 power 2. Right? Now what happens? See here, page size. Each in this example, page size equal to 2 power 2. Okay, where here n is equal to 2. Now in this example we can see the page size. See here, you can see that. Okay, 0 to 15, each page 4 bytes, that is equal to 2 power 2. Now logical address space means what? Logical address space, here you can see these are the logical addresses. Okay, now you can see here these are the logical addresses. They are not physical addresses, they are logical addresses. We are giving some number here according to the bytes each instruction takes. Now what happens? These are the logical addresses. So 0 can be written in binary as 0 0 0 0. 1 can be written as 0 0 0 1. 2 can be written as 0 0 1 0. Hope you know conversion from decimal to binary. 3 can be written as 0 0 1 1. 4 can be written as 0 1 0 0. Like that you can write. Now what he is telling is, see, page size is 2 power n, right? 2 power n, where n is equal to 2, and logical address space is 2 power m. 2 power m means this is the logical address space. In this example you can see logical addresses starts from 0 to 15. How do you write 15 in binary? 15 can be written in binary as 1111. Right, 1111. That means how many bits are required to represent this number? 4 bits are required. Right, 4 bits are required to represent this one. And here range of address, the logical address is 0 to 15. To represent 0 to 15 we require 4 bits. Right, 4 bits. That means what is the logical address space here? 2 power 4, that is m equal to 4. How this 2 power 4? Because using the 4 bits you can address how many memory locations? 16 memory locations. Okay, 16 memory locations. 16 memory locations. That is why m is equal to 4. Now what he is telling is m equal to 4, n equal to 2, then higher order m minus n bits. That is how many bits? M equal to 4, n equal to 2. That means 2 bits they use to represent the page number in the page table. So what happens? Now we will see. Okay, now in this example you can see this is the page table. In the page table, so 0 1 2 3. So page numbers, these are the page numbers: page 0, page 1, page 2, page 3. This is page 0, page 1, page 2 and page 3. Now 5612, these are nothing but the frame numbers in the physical memory. So we will see it will randomly put these page into the into the memory, and that frame number will be put here. So now this is 0, 1, 2, 3 are the page numbers. Now these are the logical addresses. Now we want to convert this logical address into physical address. Now you can see here these are the physical addresses. Okay, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the physical addresses. These are the logical addresses. Now I want to store A, right? So the address is what? 0. Now 0 means how do you write 0 in the binary? 0 is written in binary as 0, 0, 0, 0. So higher order m minus n bits, okay, they represent the page number. This will represent page 0, and the remaining n bits, they represent the page offset. So what is the offset? Offset is equal to 0. You can take any number. I will take 3. 3 is represented in binary as 0, 0, 1, 1. So here it represents page 0, and offset is how much? Offset is 3. Similarly, you can take 4. 4 is represented in binary as 0, 1, 0, 0. These two, they represent the page number. This is page 1, and offset is equal to 0. Understood? So first the logical address that you have to represent in binary, in that higher order m minus n bits, they represent the page number. Then n bits, the lower order n bits, they represent the offset. Now see, in this example he has taken, suppose the logical address 0. Okay, logical address 0 is put in frame number of 5 here. So frame, you can consider this as one frame. Frame 0, frame 1, frame 2, frame 3, frame 4, and frame 5. Understood? This is frame 5. Now page table will tell which page is stored in which frame here. Now page number 0, this is page 0, it is stored in frame number 5. Okay, now we have to map the logical address to physical address. Suppose A ka logical address is 0, B logical address is 1. Here 0, but here A physical address is 20. Now how 0 is mapped to 20 here? Now consider logical address is 0. This you have to take it as what? Frame number 5. Okay, how to convert logical address to physical address? Suppose if the logical address is 0, this is represented in binary as 0, 0, 0, 0, right? So it is nothing but page 0 and offset 0. Page 0, it is mapped to frame 5. So page 0, it is mapped to frame 5. Now what happens? Frame 5. Each page takes 4 bytes into 4 plus what is offset? Offset is 0. So what is the value? 20. That means logical address 0 is equal to physical address 20. Understood? So see here, you can see logical address 0, it is physical address 20. Like that you can do for any logical address given. Suppose if the logical address is 4, right? Logical address is 4 means it is page 1 offset 0. Now page 1, see here in the diagram, page 1 it is put in frame number 6. So what you have to do, page 1 is put in frame number 6. Each frame or page is capable of storing 4 bytes into 4 plus offset 0. The physical address is 24. So you can see here 24, right? E ka logical address is 4, E ka physical address is 24. So this is the page table. Now you can see this is a non-contiguous memory allocation scheme. Why? Because see, this one is continuously, this is one process. Now that is divided into pages, right? Each page it is put into the memory into different frames. A B C D E F G H is here, whereas I J K L is here, M N O P is here. This is called a non-contiguous memory allocation scheme. So you know what is paging, right? Fixed size blocks, each block of same size. Why paging is required? What is the difference between logical address and as well as the physical address? How to map logical address to physical address? Thank you.